Welcome students to the online learning of South International School. This is part 7 of grade 10 science, chapter number 10. Now, in this lecture we will discuss about refraction of light through a glass prism. Now suppose this is a glass prism and EO is an incident ray. EO is the ray of light that is coming and hitting the glass slab, and O dash is the refracted ray, and O dash M is the emergent ray. Emergent matlab after entering a glass slab, it again comes out from the another direction, another side of the glass slab. So whatever comes out from one medium, EO is the medium 1, O dash is the medium 2, and O dash M is again medium 1. Okay, EO is air medium, O dash is the glass medium, and O dash M is the air medium. Now here you can see that when it is entering from one medium to another medium, okay, when it is entering from a rarer medium to denser medium, air is a rarer medium and glass is a denser medium. When it is entering from a rarer medium to a denser medium, your angle R is less than angle I, but angle E is greater than angle R. That means we can say that the emergent ray is equal to the angle of emergence is equal to angle of incidence. Now, emergent ray is always parallel to the incident ray. Okay, so this is the conclusion of this activity. This activity, you can read it from your textbook. Next is laws of refraction. As we had law of reflection, we also have law of refraction. But in this law, we cannot say that the angle of incidence, angle of refraction, and the all lie in the same plane. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. You can say that the angle of incidence, the angle of emergent, and the angle of refracted ray to the interface of two transparent media at the point of incidence. Okay, at the point of incidence means O is the point of incidence, all lie in the same plane. Next is the ratio of sine of angle of incidence and to the sine of angle of refraction is constant. Now what is sine? Sine is a trigonometric value that you will learn in your higher chapters of grade 10 max. I think it is 8th or 9th chapter in your textbook. So with the help of sine and cos we can we determine the angles of certain things. Now the ratio of sine of angle of incidence, okay, angle of incidence and angle of refraction ratio, and this is known as Snell's law. As it is a constant value, it is known as a Snell's law. This constant value, whenever we are finding sine I upon sine R, that is sine of angle of incidence to sine of angle of refraction, we get a constant value, and that constant value is called the refractive index of the second medium, not the first medium. Refractive index of the second medium with respect to the first medium. Now let's discuss what is refractive index. The ratio of speed of light in a given pair of media is known as the refractive index. Now, ray of light change direction another medium. Okay, we can say that extent of change when the ray of light is changing its direction from medium 1 to medium 2. The extent of its change in direction can also be called as refractive index. Now, this is a figure in which the above one is the air medium and the box one is the glass medium. The ray of light is coming in the air medium, the angle of incidence and angle of refraction. Now, the speed of light in medium 1, that is air medium, is V1, and the speed of light in air glass medium is V2. So the refractive index of medium 2, okay, refractive index of glass medium with respect to medium 1, that is air medium, can be written as speed in medium 1 upon speed in medium 2, that is V1 upon V2, and it is determined by n/1. N is a symbol of refractive index. We can write it as n/1. Similarly, refractive index of medium 1 with respect to medium 2 can be written as V2 upon V1. Now, when we multiply both of them, the product of n/1 and n/2 is 1. How? We have n/1 as V1 upon V2, n/2 as V2 upon V1. So, when we are taking the reciprocal, we get the answer 1. If the medium 1 is vacuum, the speed of light of refractive index of medium 2 is considered with respect to vacuum is called absolute refractive index. We can say that when we are considering the medium 2 as air or vacuum, we get an absolute refractive index, maybe the opposite of this, when the light is traveling from the glass medium to the air medium. So air medium will be a medium 2. So then we will get the absolute refractive index. Now it is represented as n. So n is speed of light in air upon speed of light in any of the another medium, glass medium or water medium or anything. So we get C by V. C is the speed of light in air and speed of light in medium is any of the medium is V. So NW, that means refractive index of water is 1.33, refractive index of diamond is 2.42, refractive index of air is 1.033, refractive index of kerosene is 1.44. Water is, diamond is denser than water, so its refractive index is more. Air is less denser than water, so its refractive index is less. The optical denser medium may not possess greater mass density. Example, we have kerosene is optically denser than water. Okay, even though its mass density is less than water. Kerosene's optical density. What was optical density? The ability of a medium to refract light. Kerosene's ability is more than that of water, even though its mass density is less than water. Mass density means a specific gravity is less than water. Then also its optical density is higher. Now, refractive index of a medium does not depend on physical density. Okay. The conclusion of the above term is this. Thank you.